they have carbon. Now, what you'll do is you'll write down what they are on the periodic table, their natural state. So up here, if you look, and they're considered a solid, they're going to be the just filled in the black lettering. That's solid. If they're a gas, they're going to be red, and you got to make sure you write diatomic where they're diatomic. And then there's only a couple that would be liquid, that would be blue, and that's mercury and bromine. So this is how you showing the process of heat of formation, of the process of a compound being formed from its natural element. Okay, and that's called enthalpy of formation, and that's the values that are in the back of the book. So what we're finding is enthalpies of formation. So this is really pretty easy in the whole process. This is change of enthalpy of formation. It's a delta H of F, and then we're going to go ahead and show that. So we're going to take C, which is a solid at room temperature. We're going to combine it with oxygen, which is naturally O2 gas. Okay, and what we're going to do is we're going to make CO2. So what we're doing is we're taking all the elements that make up the compound and we're writing them in their natural form. So that one's really easy because it balances and we're in good shape. Okay, here's another one. C, this one's also really easy. When we find the enthalpy of formation of CH4. So we take C, which is a solid. We take H2, which is a gas. And then we form methane gas, which is CH4. And then to balance it, we'll put a 2 in front of that. So all of these need to make 1 mole of enthalpy of formation. Okay? So on these, when we do the enthalpy of formation, we're making 1 mole. So I always feel when we do these, let's do this one. Let's do AgClO3. So, what are the elements that make up AgClO3?
Ag.
Okay, Ag plus solid at room temperature plus. Yeah, so we have to split that everything into the individual element.
So
Yep.
chlorine.
So how do you write chlorine? Like that? It's diatomic. You got to write it 2. And then what else?
Oxygen.
O2. Now, this has to stay 1. So now we're going to do something that you have never done before, and that use fractions in front of your elements. So Ag, do we need a fraction in front of that to represent the number of moles in that compound? We don't, because we have 1 Ags. Do we need a fraction in front of Cl2 to get 1 Cl over there?
Yes.
What fraction is that?
1/2.
1/2. Do we need a fraction in front of O2 to get 3 oxygens?
Yes.
Yes.
What do we have?
3 over 2.
3 over 2, 1.5. 3 halves. So that's how you show enthalpies of formation. let me have you do a couple, and then we're going to move on to kind of show how those enthalpies of formation will work. Okay? So I'm going to just have you do a couple here. So do K2CO3. Okay, and the other one I'll have you do is NH4 ClO4. Okay, and then we're going to move on from that concept. So doing these are just enthalpies of formation. So the first one would be 2K solid plus carbon solid plus O2, would that be 3 halves?
Yeah.
O2,
Yes.
gas. Okay. Next one would be half of N2 plus 2 H2 plus half of Cl2 plus 2O2. And these would be all gases. Any questions on that?
No.
No.
So, like, why do we do this? The enthalpies of all of these on the left side are 0. So let's look them up and see if we can look them up. So you guys look them up in the back. Find AG. They give it to you. They don't give them all back here yet. They do give you. Oh, they do have a. They do have an. No, that's AGI. So what's AG? This will help you get to know it. So we're using the first column. Enthalpies of formations of AG solid. What is it? 0.
0.
Silver.
Yeah.
How about Cl2? What is the enthalpy of formation of Cl2? Yes.
0.
0. How about oxygen? You kind of see a trend here. What's oxygen?
I'm going to
0.
go and win the
0. 0. 0. 0. 0. 0.
Because if they're alone, they're...
Right. Nothing really, formed, so they're in their natural state. Now, I want you to look up AgClO3. What is the enthalpy of formation of AgClO3? Is it in there?
Yeah. -1.
I see HCl.
It's under silver. I don't see AG.
That's just AgCl.
Yep, I don't see that, so we can't use that one. How about, I know K2CO3 is back there, I think. Hope it is. Potassium carbonate. Maybe,
K2CO3.
yep, maybe it's not there
I
either.
see K2O2.
Okay, so we can't. I know this last one's there.
Okay.
No, for sure. So we can't do these two to show examples.
NH4.
Yep, ammonium perchlorate.
CL. Oh, yeah.
Negative
Okay.
295.
Negative 295.
So is that how much energy?
Right, so when K2CO3 forms, that's the only thing it's forming. on that side, and we make 1 mole of it, we know that this side's 0. We know when it forms, it's going to give off 295 kilojoules of energy. So that's what it gives off. Let's look at these previous two that we had. Find CO2. What's it give off?
Negative 393.5.
393.5 kilojoules. When 1 mole of it forms. Okay? So that would be negative. If it's outside the equation, it's negative. When it's within the equation, it's on the product side, we have to use plus. What's CH4?
75.
Okay, 75 kilojoules per mole. So all of these values, when we make 1 of them, that's how much energy we get out. Any questions on that? So now what we can do is we can translate that to a actual chemical reaction. So let's take methane. And go CH4 gas plus O2 gas gives you CO2 gas plus H2O gas, because it's going to be hot. Okay. Okay. So what we're going to do is we're going to figure out the energy of this overall reaction. So find the enthalpy of the reaction from the heats of formation. How much heat does this reaction give off, basically? Okay, so what you do is you take...
Do we balance it first?
Yep, you have to balance it, necessarily. You have to balance it. And what we need to do is give you an equation that we can use. So the delta H of standard, that's at 25 degrees Celsius, of a reaction is equal to, and this is something you might see in calculus, this sign. Maybe you guys can tell me what the sign stands for. Okay, so have you guys seen this sign in calc yet?
Heck yes.
What is that?
Or summation.
Summation.
Okay, sum, right?
Yeah.
Mm-hmm.
So it's going to be sum of all the moles of the product and the delta H of formations of the products. Okay? That's what you're going to do, and so that's what that P stands for. And I'll put products here because that's the way I show it in there. Okay? And then you're going to subtract from it the heats, the sum of the moles of the formation of the enthalpy of the reactants. Okay, so that's a fancy way of saying you sum up all of the heats of formations of the products and you subtract out the enthalpy or formation from the reactants. Okay, so this is the way I do it. So we balance it. We put a 2 here and 2 here. Then what we look up we look up all the enthalpies of formation. I think we already looked up CH4, but what is CH4's formation for 1 mole? 75 kilojoules per mole. What's O2? That's 0, right? So by itself, natural form, it's kilojoules. So what's CO2? I think we looked that one up too.
It's 393.5.
So 390, okay, so it's a negative, right? Negative 393.5 kilojoules. And what's 1H2O? So I'm just giving you what it is per mole. So for H2O, what is it?
Negative 242.
Negative 242 kilojoules per mole. Okay. So then this is what I do. Down below, if I have to multiply by how much I have. So I'm going to go ahead and do the products first. So over here, I want to find the delta of H. So I'm going to do the products first. So I'm going to go, all right, negative 393.5 kilojoules per mole, and I multiply it by 1 mole, so it'll be that value. Okay, questions on that? That's that. I have 1 mole of CO2 I produce. Okay, so I'm going to go ahead and add that to the H2O. How many do I have H2O? 2, right? So I'm going to go plus 2 times a negative 242 kilojoules per mole. And that gives me my moles cancel out. Okay. Then I put this all in brackets and I get that value. So basically it's negative 939.5 plus 2 times a negative 242. That's the sum of the heats of formation of my products. Now I'm going to subtract it from the reactant side. Well, all I have is a negative 75, right? So then I'm going to subtract it out from a negative 75 kilojoules per mole. And I only have 1 of them, so I'm just going to go ahead and write it 1. And then that's all I have. So if I want to find the heat of this reaction, then what I'm going to do is take the value of the left side minus the value from the right side. And then that's my answer for the heat of reaction. Okay, so you guys can do it. I'll do it. And then we'll see what we get. Be very careful on these. There's numbers that you're adding that are negative exponents, and so it's easy to, I know, it's easy to kind of mess up the process. But when we're all done, and you've done the calculation, that all should equal negative 802. That reaction. Is that what you get? You can double check my math.
That's it. That's what I got.
Okay. This is where graphing calculator is really nice. Because you can put everything in parentheses and...
Done.
Yep. Okay. So, that's kind of... We take the heats of formation, we put it in a reaction, and we're able to solve for anything within the reaction that, you know, we might have a certain heat of formation we don't know, and we're asked to solve for it. It might be like this, if this would be the problem, okay? And we're kind of just changing this around. So it's kind of like, all right, we don't have enough information in the back of the book, and it says, what's that heat of formation for that, CO2? So what you do is you set, when we know the heat of reaction is a negative 802, so then what we do is we go through the process to isolate CO2 and find it. Okay, math-wise. And when we do that, we'll come up with a negative 393.5 when we do that, when we solve for it. So we can solve for, most of the time you solve for the overall reaction, sometimes you solve for everything. Okay, so that was a lot of information. And then I'll probably give you guys time to work on this assignment tomorrow. Just turn that assignment in, even with that 51, if you don't know how to solve for it. And I'll look that up to kind of see how they went through and solved it. Okay? So you can hand that in. And then while you get that ready and hand that in, I'm going to go ahead and get you an assignment here that will be due on Thursday, and you guys can work on it all day tomorrow. Okay? So your assignment would be page 250. And you're going to do 84. That's the first thing we did today. There's like A through whatever on that you have to do. And then, so it's just like what we did at the beginning. And then 87, B and C. 89 through 91. And we'll have that due on Thursday.